In neuroscience, there is animal model research and there is research in humans. So one of the biggest challenges for us is to translate the research from animal models to humans. So one of the reasons is that the experiments don't look alike. For example, in the case of experiments for spatial memory or hippocampus, most of the experiments have been in rodents. And they test rodents in mazes, actually real mazes, where they record the electrical activity of the brain. So it's very hard to test a person in a real maze when you're actually recording in an MRI machine, so it's actually impossible. So when you develop a virtual reality toolbox and environment, you can homogenize these across a species. So you can actually test it with exactly the same environment and very similar settings, and that actually allows generalization from animal models into humans, which is what we call it translational research. We have developed a virtual reality toolbox that allows communicating standard software that is used in experiments with animals and humans with video game engines. And these video game engines allows you to create virtual environments that can simulate the real life situations, so that making testing of cognitive functions more realistic and making it across a species.
So there are two components to the system that Guillaume, Julio, and I put together. There's the experimental component here, and this is what we see as scientists setting up the experiment. This controls all of the parameters of the video game. And then there's the screen that the subject would see. And so for this particular video game, this is part of a learning task where the subject would navigate through this maze. They see colored objects in the environment, and they learn through trial and error which one of these two they should select. And when I say experimental subjects, there's really a wide range of experimental models we can test with this, and that's the big advantage of this system. You can do these experiments with humans in an fMRI scanner, or you could do it with any available experimental model as well.
You can think about a game where a senior actually goes with a list of items to a supermarket and pull them out of the shelf. In the supermarket, you have the employee coming in, you have some car or someone that drops a product, so you have a noise, you have things like that. So your brain is processing all this information. So the video games allows you to be a little bit more realistic, but you still have a control of the environment because we program the games. If we want to put a shelf with that employee coming and dropping some product or asking you a question, we could do it in the game, right? So we still have control. When they ask the question, when is this going to happen, before you remember the first item, the second item, the third item. So we have control. We can reconstruct the reality. So it's almost like a travel back into the past, which is very hard to do when you do other kind of psychometric testing.